So I think this is working now. Let me just check. No video coming through yet. Oh yeah, it's working. Cool, great. It has been a while again. Don't particularly know what I'm going to be doing here, so yeah, lost a little track of things. So, and that's because I've been learning just much broader than required for this very specific goal. So uh, I've signed up to Brilliant. I've only just started. I've been watching lectures from Manolis Kallis at MIT. I've been doing, rough workings out of things, and I've been just thinking about stuff. And I've also been working on a game project, um, which took a lot of my kind of concentration and motivation. So I suppose, as always, let's just start with a bit of a Greek lesson, and then we'll try and recover where we were, and then maybe that'll lead on to some more motivation for continuing this. So here we go. Snow is oh gosh, I can't remember. I think it's this because this is sigma, right? Snow, seo, 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 ste, me, sin. Okay. Yes, the cinema. So yes, it has to be no. To cinema, ste, os, sin, snow, sail, seo, cinema, que, museo, museo, seo, oops, that one, yes, seo, at, sto, uh, seo, I remember that now, ste, uh, ste, sin. Select the characters for sin, ste. The cinema is, so start is, I can't forget that one, is, cinema is a museum. Let me just double check this one. Oh, it's at. The cinema is at the museum. Oh, okay, that's interesting. The cinema at the museum. Okay, cool. That's new. That's new. The snack at the cinema. Store. At the museum. Ah, I like it. Store. The cinema at the museum. Nice, I like that. Learned something new. Cool, okay, so, wow, I'm doing really well this week. Let me close that down. Close that down. And delete that. Let's go back to our notes here. I do have a plan for this, and it's not even particularly related to, you know, any of our physics that we're trying to learn for this computational biology stuff. But at the same time, I suppose I'm trying to learn how to better think about mathematical problems, building up some kind of vocabulary to deal with formalization and proofs. And I really am a beginner, so I just thought as any of my episodes have been, I just find it interesting with the thought that someone might come across these videos one day and think, I want to achieve great things, and yet I don't know anything. Well, welcome to my world. So um, bear with me whilst this happens. We will call it episode 19 anyway, but we're going to start with this. So I was, you know what? Let's start this with a coffee. Decaf, because it's like 11:30. I signed up to Brilliant, and I really enjoyed the first couple of lessons I did. Then I went to basic mathematics, um, kind of solving things through thinking of visuals. And just the first kind of set of questions were fair enough. And then it said, if you're interested in further challenges, try these out. And so it presented a question to me, and I'll mention my dad here because I actually showed him, and he uh, made note that I was thinking of it too in too much of a complex form. So the question was relatively simple. Um, yeah, we'll go down here for a sec. Whoops. Oh, actually, that is it. Yeah. So it says, um, if you want to practice generalizing some more, here's two more challenges you can try. So what are the sum of the first n even numbers? That is 2 plus 4 plus 6 plus off to infinity. N even numbers is this whole set. So what they wanted you to do was, if I just put this again, 2 plus 4 plus 6. How do you draw these things? There you go. They wanted it so that you would end up with something like n plus 2, right? Because whatever n you're putting in, the next one is going to be uh, n plus that. It's something like that, right? But whatever it was I was doing, I'd overcomplicated it, and I kind of formed my own question. And so the question now became, if I put in this number, then I want to get I want to get 10 out, because 12 out, because 6 plus 4 is 10 plus 2 is 12. So it's the sum of all n plus n, right? Sum of all n, um, or sum of all patterns, right? Patterns that are here. Sum of all elements in the series. That's it, yeah. So so I think I just want to work on that, because it's not, yeah, directly related, but at the same time it's still a problem solving thing. And you'll see up here there's a lot of diagrams of bloody different colors and stuff, and I'll just take you through one of those. So um, if I were to say, uh, just off the bat, what might the equation be to make that a reality? If I go, um, 12 needs to be the output, and we're going to put in 6. So in goes 6, out goes 12. Uh, then then what could do that? So you could say, okay, it could be times 2, right? Fair enough, but let's just see where that breaks down. So I can't do n or 2n, because let me just put this as a green tick, and this is going to be a cross. Oh, we don't have a red. How can I configure this? There you go. Yeah. Do we like a purple? Yeah, we like a purple. Why not? So I can't do this, because if I put in 4 and I times 4 by 2, then I'm going to get 8. And 8 does not equal the actual number, which is going to be 6, 4 plus 2, right? So this does not equal uh, 6, and so we've got a problem. So this one not going to work. And I had another thought. Um, let's do this lovely. Oh, let's do little rainbow line. Rainbows are always good. So let's imagine we did something like n plus n plus 4. This is just come out of my head at some point in time. I just want to show the kind of things, the kind of reasoning behind why it's becoming a bit of a problem. Then I'd have, and forgetting the first number, you'd have 4 plus 4, that's 8, plus 4, 12. Alright, that's, oh, actually that's not what I thought it was, so, because at that point I'd need to have 6, so this is nothing anyway. Okay, fair enough. So, fine. So, where do I start essentially? I guess I'll start by drawing a graph, which I actually haven't done up here. So let me just delete all this. Not that helpful, and I'll just run through it again to make sure I get it right. So here's my graph. Oh, actually, you know what? Could I do this in Desmos? Definitely could. I just don't know if I'm good enough at using it. So let's try Desmos. Oh, let me whoops. Whoa. Glad I didn't just show my password, but also worried about signing into this. Let me see if I'm gonna bloody show everyone my email, isn't it? Oh. Well, I have no idea what my Desmos is, so that's great, really helpful. Graphing calculator. Oh, we can do it without it. Cool. Okay, so if I were to do, it's going to be x plus 2 and y plus y equals plus 4 and x equals x plus 2. Yeah, see, I'm not that great at using this thing. Or I guess it's going to be x equals what does that do? X plus 2. So if I do, okay, so that's not going to work. So if we start at how do these graphs work? Okay, let's sit back here for a second. So I know I need to just add 2 to my x. Let's imagine x is going to be 2. So let's just try and get that there first. It's 0 and it's less than or equal to 100 and the step is going to be 2. Cool, that looks good. And now let me try another one. Y equals so okay, so how do we get okay, so we need to mention both variables in there. So it's going to be x equals x plus 2 or x is defined by the variable, so it's going to be y x equals y plus 4. Aha, okay. And can I define what x is? Is that going to let me do that? No. So x is going to be y plus 4. This is always going 2. This is not going 4, so this has just become a constant. So it's going to be this one. So let's put C as 4. This is me, as I say, no good at maths, so this is great that I'm getting to do this actually. And this is going up in 2s. We don't want that, so we want this in 2s. And this in 4s. Its steepness is going to be. Oh, I see. This is the gradient. I see. This is the kind of derivative part. So if I do 0, on 2 it's gone to 8, which is wrong. So it should be 2. And at 4 it should be 6. So I guess maybe this is the problem, right? If I'm trying to plot a graph, I need to have an equation. I'm not sure. Interesting enough. So let's abandon ship on that, and let's actually just grab this chart, and I'll just start plotting points on it. Cool, I like it. This is fun. So I'm going to grab a picture of that. Oh, maybe it already has a graph drawing thing in here. I don't know if it does. Maybe not. Can I select you? Yes, I can. Wow, I like it. Okay, cool. How do I drag it? Whoa. Interesting. How do I drag this now? That one? Aha. Yes, we have liftoff. Okay. So on our graph we'll have 2 is 2, 4 is 6, because 2 plus 4 is 6. 6 is going to be 12. So we've got this kind of, it's steepening. Gosh. So it's steepening because the next one's going to be way up here again, okay? So that makes sense, right? So that's what we're roughly looking at. And so because it's steepening, I mean, obviously it's not, but let's just go with an exponent. So just to kind of prove that it's not this, we'll go n squared, and it can't be that because if I put in 2, 2 times 2 is 4, and it doesn't equal 2, right? So the input of 2 would become 4. And so that will be, so that does not equal 6. So that can't be right. Just to show that. So we've done multiplication. Let's try, and we've done exponents. Let's try a takeaway. So if I try, in fact, where's our oh, I don't know the marker. It's too hard to see it. Actually, they're all a bit too hard to see. Let's go for a grey. Okay, cool. So the next one, yeah, let's try plussing. So if I were to say what needs to be plussed to 2 to get 2, well, it has to be 0, right? So if I have the number 2 and I need 2 out because 2 plus nothing is 2, So 2n plus c, c is a constant, um, the output will be uh, not equal not equal to unless, well, I mean it'll have to be 0. So if I do, rather than c 0, then we'll get 2 out, right? But then if we add anything else, this is where it breaks down, right? If we add anything else, n plus c, then it will not equal to so 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 it does not equal to. So this is going to be a pass, and that's going to be a fail. Cool. So we're just building up some kind of fundamental facts about this problem, right? And I was explaining to someone else that I'm just trying to avoid I'm trying to avoid like a symbolic interpretation of it at the start to keep it simple, because I still need to build up those tools in my head. Um, if maybe you would try to use something like you take your graph and you apply a Taylor series on it to try and get your expression, um, whatever, whatever. So and that's exactly what I need to do. I probably won't go that far, but regardless, anyway. So we've done plussing, and what about just subtraction, right? So let's give these little headings as well. I say Taylor series, by the way, because I got a shirt with it on, so I know about that one. So let's go exponent. Whoa. And this is uh, multiplication. Let's see, multiplication, great. And this is going to be uh, addition. And this one we'll give it a try with subtraction. And I hate the fact that I didn't do that as a capital, so I'm definitely going to correct that, and I'm definitely going to correct that because it's just, headache, 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 headache. Exponent and multiplication, traction, doesn't look very good. Okay, great. So if I were to put in 2, what can I get out? Well, it'd have to be n minus 0, which would give us 2. Why am I doing this? This is dumb. Bear with me, sorry. Uh, I meant to... Well, I suppose it works in this matter, but this is supposed to be input and then the other thing. So it's like 6 times 2 equals 12, right? Yeah, let me just rework it because I really want this to be working as a proof for me. So let me do this again. Sorry. Right, starting from scratch. So 2 times 2, for that's n squared, is equal to 4, so it's a non-starter. And that's that's power of 2. Uh, or to the power of, yeah, to the power of 2, there you go. That looks better. Cool. And this one will be unerasable apparently. Always good to know that's not now working. I don't like this tool. I'm not sure I like it. We'll progress, we'll push. Okay, right, so this is going to be 2 plus 0 equals 2, but 2 plus c, uh, where c is not equal to 2, is not equal. Oh, sorry, equals uh, less than or equal to and greater than or equal to, or less than and greater than or greater than 2. That's the one. And then this is going to be 6 times 2 equals 12, and that's the tick, but that one's going to be anything else 4 times 244, and that's going to be 16, which is wrong. Well, okay, sorry, I see. 4 times 2 equals 8. So this one's correct, this one's wrong. And so finally, oh, we didn't mark this one right. Tick. But across, and then we've got 2 minus 0 is of course 2, but it breaks down if it goes at anything else. 2 minus c equals less than or greater than 2, whereas I need to correct this as well. Let's see if there's a symbol for that actually, bear with me. Math symbol for greater than or equal to, greater than or less than. Greater than and less than symbols, let's see. Khan Academy, always good, but I want to know where there's an or. So for less than or greater than. So for less than or greater than. Not equal to, that's good. So we'll do that as well. We haven't got that used here, but that's fine, it's good to know. I guess there isn't one. Maybe there isn't one. Just use the word or. Seems fair enough. Combining. Oh, okay. So you state it. So it's less than 2 and greater than 2. Oh man, that's gone wrong again. Good. I like it. So it's less than 2 and greater than 2. Well, that's and. That's a problem. Changing sides. Let's just say it does not equal 2, right? Yeah, that's probably better. That makes a lot of sense. Does not equal 2. Now we've got a nice little symbol. Does not equal 2. There you go. There's two reasons why I needed to do this. So that's great. I've learned something already. Okay, cool. So we've got like like a non symbol proof that just at least those very simple operations aren't going to work. So now we need to think about adding two numbers. So let's think an equation with two numbers or two variables is what? And it is called a linear equation in two variables. The two variables are the x and the y. Let's see, what's an equation with three variables? An ordered triple. Let's see. Example of three variable equation. 3x plus 4y minus 7z. Yeah, okay, that makes sense. And 2 is going to be the other thing. So we're gonna have a 3 variable, which is gonna be... Okay, cool. So, next thing to think about is the distance between each number and the pattern itself, right? So the pattern, put this as problem, and then let's call this operations without, or yeah, that's fine. Just do operations. Okay. Exponent 2, multiplication 2, 2 or anything really. Addition C, subtraction C. Yeah, fine. In fact, I think this really proves any of these. So to C, let me do that. C. So pattern is n plus 2, and the distance, or the derivative of n is plus 4, so it's n plus 4. No, it's not. I don't know why I'm saying that. It's clearly not, because otherwise that would be the that would be the answer, right? Okay, let's try that again. Maybe we should draw out a table like I've done before with the kind of derivatives and get some answer from that. Let's put that there. Delete this. We can delete some of the other stuff as well. Oh, it's all gone anyway. Okay, fair enough. Don't think this was that helpful. And so now we're going to go for a table. So column 1 will be the inputs, input, and the column 2 will be the sum of n. And it's going to be like a tally, I guess. So let's zoom in. 12 is 12. Purple is a very bad color. I shouldn't have chosen that. yeah, so we'll go input's going to be 2, and so the sum of 2 is 2, and then 4, and the sum of 2 plus 4 is 6, and then 6 plus 6 is going to be 12, and then 8 is going to be 20, and then 10 is going to be 30, and then we'll do 12, which is going to be 42. Okay, a little bit more. Let's try and build up a kind of good intuition here. And then 14 will be 56. Let's see, 40, 52, 46, 56. And then we'll go 16. That's 12 plus 10 is 22, 72, right? Let me just check myself. 56 plus 16, 72. And then, let's see, 18. That's going to be 10. And then 10 is, sorry, 72 plus 18. 8 plus 2 is 10. 7 plus 1 is 8. 80, 92. That can't be right. I think I've done a mistake here. It's okay. This is why I work late, you see, because then I can blame the lateness on everything. And let me also just check my volume's coming through. It is. Cool. So 72 plus 18, 90. Cool. That makes sense. I knew it didn't work right, but and then 20 finally we got 110. Cool. So we've got a nice little table there that's going to help us. So what's the distance between each of these? So let's do the derivative. It's going to be the derivative of this. Let's go for it. So 2 is 0. This is 2. This is 6. This is 8. This is 10. 20, no, it's not. This is, and this is, hang on, 20 and 12, yep. 20 and 30 is 10, yep. 12, and, oh yeah, silly me, yeah, it's going to be this, right. So, yeah, that was a bit silly, actually. Interesting, though, that what am I trying to say here? This is, what's the difference between these two? That's what I want to do. Let's try it again, sorry. So it's going to be 4, and the difference between 6 and 12 is 6. The difference between, well, 6 and 2 is 4. This is 6. 20 and 12 is 8. 10. 12. 14. 15. So this one is, this between 6 and 2 is 4, but 2 and 0 is going to be 2, I guess. If we assume that the first one is 2, so that really is the same. Yeah. And this is my worry, that I'm overthinking things here, so yeah. That is not helpful. That column is not helpful. But we're doing it anyway. Here we go. Okay, cool. So now what do I need to do to kind of think about things? Let me see. How can I resize this? Oh, That's actually working. Can I resize you? Resize you? I don't know. Please? I've only got two buttons to work with it. I guess you can't. Okay, cool. Right, fine. Next step. What are we going to do next? What are we going to do next? So I did draw some pictures to kind of visualize as Brilliant suggested. So let's do that. So if we were to start with, you know, going up with these, we start with like a cube like this, right? There's a square, and then the next color up, let's call this the red. This one's going to be green, and we'll do white as well. One, two, three, four, and then one, two, three, four, five, six, and then finally eight. One, two, three, four, five, six, seven, eight. And I thought this was kind of interesting that just get a yellow, for example, that the going up here, um, no, that's not interesting. Okay, yeah, cool. So that's 2, 4, 6, 8. Does it grow in any kind of specific way is the question. Well, it's always got its like let's give these indices, right? So if I were to say this is indice, in fact, haha, let's do that. If I were to add another column here, and we'll call this I for indices, or index, sorry. This is index 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's put little lines in here to make it look sexy. Okay, yeah, so if I were to add, this is 1, and this is 2, and this is 3, and this is 4, so this is I, and this is N. What we got here seemingly is 1 plus 1. It's just a bit of a sketch here. 1 plus 1. Then you've got 2 plus 2. Plus 2. Plus 2. And then you've got 3 plus 3 plus 3 plus 3. 3, oh no, sorry, yeah. 3 plus 3 plus 3 plus 3. Does it work for the next one? 4 plus 4 plus 4 plus 4 plus 4. 4 plus 4 plus 4 plus 4 plus 4. That's going to be 16, 20. Looking good so far. Now I did see that one broke down after a certain amount, so I'm going to do another one, 10, and I'm going to do 12. What colours we're going to go for? Let's say, ooh, let's get a blue. I like blue. 1, 2, 3, 4. Ooh, nice. 5, 6, 7, 8, 9, 10. What colour this one? You should probably have another column here, to be honest. Let's do that as well, so I can label it right. We'll call this color identity or something. Okay, and that's going to be identity 5, and then I think we'll have one more color to be fair. Which one am I missing? Got the blue, got the white, yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, cool. And this is index 6. Which I think that's a bit confusing now, but it's okay. So that works for that. Now I'm going to try the 5. So 5, 5 plus 5 plus 5 plus 5 plus 5 plus 5 equals 10, 20, 30. Sorry, 10, 20, 30. That's correct. And then we've got, so I think we've come up with our solution here, haven't we? And then this is, we're going to do 6, right? So 6 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6 equals 1, 2, 3, 4, 5, 6, 36, 42. Alright, and that's matching this, and I think that's a safe bet, isn't it? So I think we solved it. So this is how do you draw those color things like this, isn't it? Something like that. Something like that. Oh yeah, getting all artistic here. Okay, so now we can say that it's the index on the pattern. So it's the index of the pattern. So if this is I, let's go into over here. I can you actually see anything? Let me just make sure you can see stuff. Oh, it's really blurry. Wait, is that just me? That's just me. Okay. But the purple is terrible though. I really apologize. And let's transition to pink. Let's transition to pink. That'll be a bit easier. Maybe even thicker, can I? Oh yeah, we can go thicker. So I still not that thick. So I for index plus 1 will give you 2, right? And there's going to be, so that has to be part of the equation, right? So it's going to be I plus 1, and then for this one it would have to be plus 3, and this one would be I plus, so this is 1, 2, 3. 2 plus 1 is 3, plus 3 is 6. 3 plus 3, 3 plus 1 is 4. Plus 4. Okay, so here we start to break down. So let's try this again. So let's actually try this again. That does not look good at all. This should be easy now. It's basically, because I need to do this, it's n minus 1 times. So if n is 2, then for I equals 1, I should do n something like from n to from I equals from I to n, that's going to be I plus I plus n. No. Right, so for I equals 1, from I equals, from I all the way to n, which in this case is 2, I want to do plus n plus n. So what's the sum of all this? So if I go, so the first one, say, go piecewise here, we'll go 1, no, we'll go 2 plus 2, and this is iteration 1, and this is iteration 2. 2, 4, it's just plus n, isn't it? It's whatever it was plus n. How do you do that? Oh, hang on, it's factorial. No, it's not. Wait, haha. is the product of all positive integers less than or equal to n. Sorry, okay, so it's not that. And also, uh, yeah, how to use sum of symbol for plus summation symbol. It's the sum of all. Okay, let's try this again. So for 2, I want to do so sum of where from I to n. So this is going to be, so this will be 6, so that's not right. It's actually from 0 to I. From 0 to I. And then what we're going to be doing is it's the sum of n. So on the first loop, it'll do that's not going to work either. From 0 to I, because it's going to go from 0, 1 to 2. So maybe I need to do from 1 to 2. From 1 to I. So now this will start at 1 and it will get to 2 and there's nothing else to run. I don't like the way it doesn't do that. From 1 to 2, or would it be from n? No. I mean, there it is. It's just so annoyingly simple. Why am I not doing this? It's n minus 1 in this case. But why did I do 1 plus 1? It's just not obvious for that one. So we start from 2. So if this was 2 instead, then that would be 2 to 2. Then you just add n. And then this one would be 3. So it would be 2 to 3. So it would be 4. Oh no, it'll be, it's not even n, is it? It's definitely not that. It's add I. So this would be 1 to 2 would be I plus I. I think I've got it. Okay, so from 1 to 2 would be 1 plus 1. And so from 1 to 1, we got it, we got it, we got it, we got it. We've actually got it. So from 1 to 1, I equals 1 is going to be 1, or should it be 0? Because then we've already got there, so it's going to be 0 to I. Let's try that. It's 1 plus 1. Don't, it has to be that. It has to. So 1 to 1, we just run it once, so it'll be 1. But it will be 1, so it needs to be 2. Okay, sorry, I'm being an idiot. So it'll be 1 and then plus 1. Okay, we got it. And the next one will be, so I really am an idiot. So it'll be I is equal to 0, and it'll be I is equal to 2. So I'll do 1. No, I is, and it can't be I either. Yes, it can. It'll be the max of, so this'll have to be another number. So this will have to be I2, so I equals 0 to, let's call this C. No, let's call this, um, let's call this N. No, let's call this, yeah, why not? Because I'm not using it anywhere else. And so now this will be better. Cool. And this will be the sum of N, which in this case will be 1. Ha! How do you formalize these things, eh? It's such a simple thing in code. Such a simple thing in code. Right, coffee. I feel like chucking this away and starting again, because this is it. We have it. It's the sum of itself, because this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and so on. So it's always going to be like what the number is. This is 7, right? Yeah, 3, 6, 7. What number is plus 1? So it's like I plus 1 is the top of it. And then it's and then it has to start at I, and then it's not plussing I, it's the start of I plus 1. But then I is incremented, so we have to say that this is equal to something, right? And so it's going to be n this many times. I mean that's it, right, isn't it? I just don't know how to write this, to be honest. Maybe that's how you write it. But and it can't be that because I is incrementing, so it's going to be set per thing, and so it can't be self-contained. You see, because if I did I, then then this on the next iteration would mean that this is fucked up. So um, but it is from it's from it's always from 1 to 1 plus 1 to I plus 1. But then I is the incrementer, so I must I must equal 1 at the beginning, and it must end on so we need to set some variables here. Let's do that. So the variable is uh, index input equals, and then we've got the actual running index, and then we've got the total iterations, and the index input is just going to be called let's call it P, or input I. Let's be a bit sexy here. What's the Greek letter for I? How do I get a keyboard up? It's that. Fair enough. It's not that interesting. But it's still different. It's still different. So we're going to call that one I. And then this is going to be, running index will be I. And the total iterations is going to be the input plus 1. Which we'll also call, well, that's fine for now. So let's see if we can make some progress here with these variable names, because we can see what the problem would have been then. So now I can go, I want the sum of, from the index input to the running index is going to be I starts from 1, sorry, and it goes, and the index goes to the total iterations, which is this plus 1. And I at any point is just going to be plussing. So okay, so let's say I put the number 1 in, I should get 2 out. So it's going to be the sum of uh, this, the index input. And if I put in 2, it'll, so let me just do this. So here it is. Oh, that's big. And I meant to do that one. So this is going to be for 2 iterations. Because I'm going to put 1 in, and it's going to be plus 1. So this is 1, and it's going to be 2. So for number 1, it's going to be 1, sum of 1, and then for number 2, it'll be 1 plus 1, which is the running the index input, and then 1 for the for I for the plus 1, sorry. And then this one, let's go for this one, the input was 1. And now for the input 2, we've got 1, 2, plus 1, 3. So this one will be 1 uh, 1 plus 2. Sorry, it's going to be 2 because that's my input. Then it's going to be 2 plus the last 2. Then it's going to be 2 plus the last 2, or 4 plus 2. Good, we've got it. So that is an equation that will work. With the above, the index input, the running index, and the total iterations, it's actually just from one to anything, isn't it? So no I is required. So we can get rid of that. And it's just the index input plus 1. So there we have it. That's one solution to this problem. And I suppose now we haven't got that problem, we could call this I, right? So let's just call this I instead. I mean, that's it. That's a pretty basic equation. Okay, not bad at all. And that came from all of this working out. So we went through the kind of typical operations, an exponent, which kind of came from just drawing that graph. I thought it's getting bigger, but it's not exponentially getting bigger in any shape or form. And this kind of proof it doesn't work. And any subtractions or additions isn't going to work, and then the multiplications neither. We diagnosed the pattern was always plus 2. We built up a table to give us a kind of intuition on uh, the numbers. We gave them colors and we drew this diagram, and this was helpful because then we saw, you know, by giving it an index, we were able to get a pattern out. And then after a bit of play, we decided it wasn't working just by going mad, so we just put the variables up front. What's the index input? It's going to be 1, it's going to be 1, 2, 3, and so on. And then the total iterations is just going to be whatever you put in plus 1. And then of course this is the sum of all of those iterations. So we tested that, but with just 2. Now I wonder if we can do that in Desmos now. So let's see if that's possible. I don't know if you could do sum of. Maybe there's a. Oh, here we go. Functions. Total. Total sounds good. Total of I plus 1. And I is. That's it, so it's going to be x equals. So it's going to be y equals the total plus x, or x equals that, and then this is going to be from 1 to 20, stepping 1, and this is what does total do? Let's find out. I don't know what total does. Stats total. Oh, it's got the sum of here. Here we go. Let's see if we can play with that. Sum of. Okay. So it's going to be 1 to y plus 1. What does that say? What do you want to take the sum of? Does it not give me? Oh, here we go. So it's going to be y. See, that doesn't look right. X is equal to the sum of that, but that's interesting. Why is it done that? That is very interesting. I don't know how to configure those values though. I guess maybe if I do Z. Yeah, okay, so we'll do J, or maybe we can do I, cool. And then I will be a range from, there we go, 1 to to 20 in step 1. Cool. And then what y is not that, it needs to be that. And then that's the y value, and then the x value I don't know how to plot these things. Can I do like a hard-coded? Oh, what's this table here? Ah, haha. Okay, we're getting somewhere. So if x is 2, y is 1 plus 1. What does this say? Table entries must be simple expressions. This type of expression is not allowed. That's interesting. I must be able to plot this. I just don't know the tool, I suppose. Let's try this again. How to plot a graph in Desmos with x and y value without like an equation. Because y would be that, and then I want another one. X for each iteration, for each step. X is going to be, yeah, x is going to be a variable, right? Um, X is one of those slider things. How do I? Um, can I do that? Is that gonna? Clearly no idea what I'm doing. I don't need that though. What does this say? Lower bound of a sum must set a variable equal to a number. Try n equals 1. Okay. I is the input. I is the sum. We don't need that. It's kind of cool because you can actually see that kind of graph that we did happening there. But I has not been defined, and I needs to be defined. Define variable in Desmos for sum of equation. Yeah, because you can also put a parameter for the upper and or lower limits. Parameter. Okay, let's see. I equals 1. Okay. N will always equal 1. And this is going to be from 1 to 20, let's say, in stepping up in ones. Cool. And then x is going to be, let's see, x is going to be x plus, what was it, 2. Mx plus c. Y equals, m was what? M's the gradient, m plus mx, so it's times x. What does this say then? Y equals m. Let's put that all in there. Mx. Uh, how do I do x then? X plus c. Plus c. C will be 2. Guess not, because that's the offset. Right, yeah. So it's not that. Let's say, well, at x2 should be 4, and at x4 it should be it should be 6, and then at 6 it should be 6 it should be 12. Hang on a second. This doesn't look right. How do I configure these as well? That looks good. So 2, 4, and this is 8, and that's wrong. And I is 1, and it's going to go, and it goes up. Each step, I guess. I mean, if I click on this again, it is stepping by one, yeah. If I did two, what happens? No, that's interesting. So that is not doing anything. Add slider for I just want it to be. So this is just giving me the gradient, I see. So, okay, I see. So, if I'm gonna plot it, I just need to put the actually hard code them in. So, um, I might ask about this on some forums, but I have a funny feeling that if I just put the numbers in that I calculate, uh, it doesn't seem quite right. I should be able to just um, 'cause it's just going up in ones, so I needs to be itself plus one. I don't know if you can do that here. Hmm. See these expressions again. What they got again? Functions. Uh, well, okay. I don't want to waste this video's time anymore. So that was good. So it's at least one solution to that problem, and a nice set of kind of you know just a thought process that led to that, and that's the kind of thing I'm trying to build up. So happy with that. And just as a note for myself, when I was in the pub and stuff trying to figure this out, I got a little bit lost, to be honest. And I think it's just this documentation of how lost I got. See, I started with. Oh, trying to find the page now. Here it is. Yeah, I started with um, drawing these kind of things. I have to just wait till I can actually see it on the screen here. So got the equation, then or the pattern, then I drew some kind of drawings of it, and then I've got my table, and I started making calculation mistakes. Uh, that didn't help, so I tried again, and then I started to draw, or started to tease, um, with a summation, with Z for real number, and I was trying to make it equal, but I was using the input number rather than the index number. You see, um, no, that's interesting. That is interesting because I've lost the input here. So I'm not using the pattern. There you go, it might be another problem. And then I was trying to think of the area left, so integrals and stuff, um, and so on and so forth. Now it's interesting that I've gone and a little bit over here as well. So it's interesting that I've really lost, all notions of the input number. So let me just think about this for a second. I these ones here have been lost in the ether, but I suppose it's always just times two, right? So um, and it's not even like, to answer the question here. This is the array given to you of values that I want to sum, and it just so happens that the sum of the index of them is actually the answer. Now, is there a way to is there a way to get that by just using the input? And I suppose it could be. You can see how, and so I won't waste any more time on this because it's just not relevant to anything. Just part of that kind of learning process. I think I'd prefer to go and find another challenge that interests me again. Um, but it's great to see that you can start with such a simple question of, what what's a good equation to get the sum of all of these n's at any given point. Um, what's the kind of operations you have to go to get to a reasonable answer, essentially. I mean, this is fine, and if you were to be given a pattern and you would say, okay, let's declare I as the index input. This makes sense to everyone, I think. So, uh, do I feel like giving up now or going away. It's 1 o'clock. Maybe I should just okay. Let's just have one little think more. So if we're trying to use the actual numbers, which it'd be kind of cool. Um, yeah, no, it wouldn't be cool because I mean, you'd say, okay, at the nth term, what what would be the sum of it? Then you'd have to already know. You'd have to do a calculation to do that first. You'd have to say, okay, for 20 it'll be times 2, um, because it's 20 times 2 is because it's human numbers, and only then can you can put it in. And so yeah, I don't see any reason to do it that way. Yeah, happy with that. So yeah, see you guys later, and who knows, maybe I've got the week off, so maybe tomorrow I might spend a bit of time on this, but I might not. So uh, ciao for now.